Hello everyone. So today let's solve the problem one-way reform, right? So this was asked in the Codeforces round 375 for the division 2, right? So let's see what the question states here. Just give me a second, 1 second. Yeah. So we are given n cities and m undirected roads. See, we are given n cities and m undirected roads, right? So what we need to do here, we need to orient all the roads to maximize the number of cities, right? So we need to orient the number of roads to maximize the number of cities actually with equal incoming and outgoing roads, with equal incoming and outgoing roads, right? So we have to output the maximum number of such cities. We have to output maximum number of such cities actually. We have to output the maximum number of such cities and one possible orientation of all roads and one possible orientation of all the roads, right? So multiple answers are also allowed for the same input, right? So just keep this in mind. So let me read the question loud. Again, just listen to this carefully, man. We are given n cities and m undirected roads. So we need to orient all the roads to maximize the number of cities with equal incoming and outgoing roads. With equal incoming and outgoing roads, we have to output the this one maximum number of such cities and one possible orientation of all the roads. So multiple this one multiple answers are allowed for the same input. Just remember this one, right? So see here, we have been given the input C, 5, 5. These are the edges basically, right? So the output that we need to get here is this one, 1, 3, 3, 5, 5, 4, 3, 2, 2, 1, 3, this one, right? So this is fine, man. Let's do one thing. Let's quickly discuss the, as we are familiar with this one question as well as the input output. Let's quickly discuss the approach followed by the complexities and then let's write the code, right? So multiple answers are allowed, right? So let's do one thing now. First of all, we'll be going with a DFS, right? So we'll be making use of the DFS to solve the problem. Depth first search. Just remember this one, man. Right? So first what we will do, the first step here, um, we will count the degree. We'll count the degree, number of connected roads of each city, right? Number of connected roads of each city accordingly with the input. Let's consider this example for the this one approach. So for the city one, for the this one, what do we call, for the city one, we have this one, two roads connected basically. For the city one, you can just look into this one basically. Input for the city one, we have two roads, right? For the roads, I'll just write here R basically, right? So for the city one, we have two roads. For the city two, how much we have? uh this one, right? For the city two also we have two roads, right? So I can just draw the graph as well. It will be easier to follow basically, right? For the city three, we have three roads. For the city 3, we have 3 roads, right? For the city 4, how many roads we have? For the city 4, we have 1 road. For the city 4, we have 1 road. Finally, for the city 5, we have 2 roads. For the city 5, we have 2 roads as well, right? So this is nothing but we are counting the degree, nothing but the number of connected roads of each city, right? So for the city 1, we have 2 roads. For the city 2, we have 2 roads. For the city 3, we have 3 roads. For the city 4, we have 1 road. And for the city 5, we have 2 roads, right? Next, what shall we do? For the cities with this one, sorry, for the cities with odd degrees 3 and 1. So see here, this one. For the city 3 as well as the for the city 4, we have the odd degrees, right? For the cities with odd degrees, this one 3 and 1, we will be adding a dummy edge to the virtual node 0 to make all the degrees even. So again, for the odd degrees, what we are doing, we are adding a dummy edge to the virtual node 0 to make all the degrees even here, right? So then what we will do, we will perform the Euler-Tour DFS, right? Recently, we have discussed the algorithm Euler-Tour technique as well within the tree-based algorithms, right? Very recently, we had discussed, if you remember, right? So we will be performing the Euler-Tour DFS on the modified graph here. Every time we traverse the edge, every time we traverse the edge u comma v, so we will remove it from the adjacency list. We remove it from the adjacency list, right? that is what we will be doing. So the maximum balance cities is equal to the so how we can find the maximum balance cities here? Maximum balance cities will be equivalent to the total cities minus number of cities connected to the dummy node 0. Total cities minus number of this one cities connected to the dummy node, right? Connected to the dummy node, right? So that is cities with the odd degree basically, right? Here in this case, we have 5 cities, right? 5 cities. And what are the this one? What is the count of the odd ones here? Basically, odd ones here 3 and 1, basically 2, right? So 5 minus 2, so this will be 3, right? So this will be 3. Balance cities would be 3 basically here, right? So balance cities would be 3. See here, this is how we got 3, and we are just we have to display the edges as well, right? After that. So this is the thing. Basically, this is how we got the output 3 here, right? So the output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big O of n plus m. So why the time complexity here is big O of n plus m? So we are making use of the DFS, and we know that DFS visits each this one every edge case basically. So overall time complexity would lead to big of n plus m, right? So what would be the space complexity here? The space complexity would lead to big of n plus m as well, right? So what would be the space complexity here? The space complexity would lead to big of n plus m, because we will be storing the adjacency lists in the tree set. So overall time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus m and big of n plus m respectively, right? As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So now let's do one thing. First, we will be making use of the fast input and the output along with the different utilities, right? So let's import input output here, input output package. Sorry, 1 second. Yeah, along with the different this one utility package as well. Sorry. Yep. Now let's make use of the main basically, right? So this is fine. Now let's go with the variables for the number of test cases, cities, roads, as well as what are the things that we need to consider, and the cities of each road, right? So these things will be going with variables for the number of test cases, cities, roads, and cities of each road. Also, let's go with a graph adjacency list, and let's go with a print writer for the fast output. These things, let's do this one very quickly. Just give me a second here. So static int, let me go with t comma n comma m here. This is fine. U and v, graph adjacency list. So this one, I'll just go with static here, reset here. So this is fine. Integer, we give c. Now let's go with static here. So let me go with a print writer. So this is out, right? So now let's move on with the main method man. So I'll just go with main here. Let me remove this one. Yeah, let me go with throws exception. This is fine. Yep. Yeah. Now, within the main method, what shall we do? Let's go with the buffered reader. So I'll just go with buffered reader. We are new buffered reader. So this is fine. New input stream reader of system dot n. This is fine. Also, we have made use of the out variable for the print writer, right? Out equals, let me call here print writer, make it system dot out. So this is fine, man. The next part is we have to read the number of the test cases, right? So in our case, see, yeah, this is fine. We have to read the number of test cases here. So this one will be t equals integer dot %, as it is integer, we have considered br for the buffered reader variable name, and let me go with the read line here. This is fine. Yep. Now while t greater than 0, now let's do one thing. Let's read n and m1. So this is simple. So I'll just go with string is equals buffered reader dot read line. I'll just go with a split. Yep, this is fine. Now let's go with n and m. N and m here, n equals integer dot percent s of 0. Right. So this one, yeah, m equals so integer dot percent s of 1. Right. So this is fine. Now let's go with a tree set one. I'll just go with tree set. So this is integer. This is fine. Gg equals. I'll just go with new. Let me give tree set here of size and plus 1. We are just creating the adjacency list one in simple terms. Let me assign g to gg, the variable that we have considered above. Right. So let's move on with the iteration part. Here we have to initialize each set here, right? So this one I'll just go with I equals 0, I less than or equal to n. Let me go with I plus plus. So g of I, let me assign this one to the new tree set, right? So this is fine. Yep. Yeah. Now let's do one thing. I'll just go with a while loop. So this one while greater than 0. Now is equals buffered reader dot read line. So let me go with split here. Yeah, so we have successfully read the each edge. After reading the this one each edge, then let's go with the edges u and b. So which are of the type integer, right? We have to read them as well. I'll just go with integer dot percent of s of 0. We have to pass here, right? So let me copy the same thing and make the necessary changes here. So let me change this one to v, and let me change this one to 1, right? So this is fine, man. Now g of u, this one dot add of v, this is fine. We are just adding the edge from u to v, and also let's add the edge from v to u as well. So this one g of v dot add of. So let me come out of this one entirely. Now let's add the dummy edges to the virtual node 0. Accordingly with what we had discussed on the this one approach, let's add the dummy edges to the virtual node 0 for the odd degree cities, right? So this is simple. Let's do this one very quickly. So this one will be int I equals, oh, we have to start with 1, right? Yeah, I less than or equal to n plus plus. So if I would have started with a 0, it would have given me error. So this is fine. So now if the degree is odd, then we have to connect to the virtual node 0, right? So let's write the simple if condition here. G of I, let me go with size here. Size works. Bitwise and 1. This is fine. If it is equal to 1, then let's do one thing. Let me go with G of I dot add of 0. Right. Also g of 0, let me go with add of I. This is fine. Now let me come out of this one entirely. Now let's do one thing. Let's go with a maximum balance set is nothing but n minus number of odd degree, right? So that's what we did in the approach. Let's try to implement the same thing in the form of code here. So this one will be out dot println n minus g of this one 0. So let's make use of the size here because we are going with n minus number of odd degree, right? Odd degrees basically. This is fine, man. Now we have to perform the DFS just to orient the roads, right? Just to orient the roads, we have to perform the DFS, right? So before doing this, before doing this, um, do one thing. 1 second, man. Yeah, so we have to perform the DFS to orient the roads. Yeah, this is fine. Yeah, let's do one thing. Let me write the this one. What do we call DFS function? Then we can make use of it within the main method. So let's write the DFS functions to traverse the edges and uh, for printing the this one oriented edges. So I'll just go with static void DFS parameter u. So let me go with a while loop here. While not of g of u, this one dot is empty. This is fine. So within the while loop, so basically when we are considering while there are edges basically, right? So then only we can move forward. So first within the while loop, we have to take one edge. We have to remove the edge from u and v, and then finally we have to print the edge only if not connected to the this one. What do we call? Not connected to the dummy node. And finally we have to go with the DFS on the next node. These are the things that we need to do, right? So first let's take one edge here. So this one will be in v equals g of u dot first here. This is fine. Next, g of u dot remove of v. Yep. Next, g of v dot remove of u. Fine. The next step would be we have to print the edge only if not connected to the dummy node, right? So how can we write that one in the form of code? Let me write the if condition here. U not equal to 0 and v not equal to 0 here. So let me go with out dot println. This is fine. U plus yeah plus v, right? So this is fine, man. Final step is we have to go with the DFS on the next node, right? So let me recurse here DFS of, let me pass v. So this works, man. Yeah. So somewhere I don't know where I did something wrong, man. Damn, bro. So this is fine. Now let's move on. Some I have misplaced the brackets. I don't know where I have misplaced the brackets. This is fine. Let's move on with the this one for loop. Basically, we have to perform the DFS to orient the this one roads, right? So I'll just go with for here. I less than or equal to n. So we are performing the recursive DFS here, right? So if you observe correctly, so see here, we are going with the recursive DFS here. So now continue the code with the main method. If not of g of I, let me go with is empty here, then we have to start the DFS. So here this will be DFS of I. This is fine. Finally, let's do one thing. Let me go with out dot flush here. So because we have to flush all the output at once, right? So now we are done with the code. Before checking the code with the different inputs, so let me do one thing here. Let me copy paste the signature starter template. Just give me a second here. Let me paste this one. Let me come to the question. Let me copy this one. Yeah, paste this one over here. Let me give some icon here. I forgot, I think. Yeah, let me run this one again. String I have given, line number 63. So this one has to be static, man. Yeah. Now let me run this. Illegal start of the expression. Void DFS. Static void DFS. This is correct actually. Into. So let me remove one bracket. Bracket is the main problem, I believe. Illegal start of the expression. Why? What happened, man? So we are just going with the DFS function to traverse the edges and printing the oriented edges right here. So we have to go with static void this one DFS. What's illegal here? Huh? I don't understand sometimes. Really don't understand sometimes. Just give me a second here. So what mistake I have done here is, so I had put this one. This DFS is within the main method now. So this one I removed one bracket and I forgot to place it here actually. This for loop I didn't close at all. Here itself we have to close basically, right? So let me run this one again. Yeah, we are getting the output, right? So 3, 3, 1, 1, 2, 2, 3, 3, 5, 5, 4, 3, 2, 4, 3, 7. Right? Right. So this is also one of the valid outputs, right? So we have got here 1, 3, there we have got, for us we have got 3, 1. We got 3, 5 and all. We got 1, 2 instead of 3, 5. So here we got 3, 5 in the different order basically, right? So this is also fine. This is also accepted, man, I believe. So let me copy this entire code. Let me come here. Yeah. Let me select here E and let me paste it over here. And let me hit the submit button. I hope this works for all the test cases. Let's see. So here in the toast, it is showing accepted, right? So the verdict that we got here is accepted. So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear, man, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.